The new SmartBob2 combines technological advances and common sense to give you the strongest and smartest inventory measurement system on the market. The new robust design of the SBR2 remote sensor will provide years of maintenance-free service in vessels up to 150 feet. It's built tough to cut through applications where sonic pulses, high-frequency signals, or competing bob systems can be stopped dead in their tracks. Here's how SmartBob2 works. An SBR2 remote sensor is mounted on top of the vessel. A motor releases stainless steel cable from a supply pulley, which causes a weighted sensor probe to quickly drop from the top of the vessel to the surface of the material. What we are actually doing is we are measuring the amount of cable released with an optical encoder and a pulse wheel, which pulses at about 80 times per foot. This pulse wheel is directly connected to a timing pulley on the mechanical side of the unit. As soon as this sensor probe reaches the material surface, information is transmitted, pulses are momentarily stopped, and the microcontroller alerts the motor to immediately pull this bob quickly back to the neutral position at the top of the vessel. We are measuring the pulses as we go down and descend, and also on the retract, and we are comparing the two so that we can assure that this bob always makes it back to the top of the vessel. Mechanical features of the SmartBob2. The mechanical and the electrical cavities of the unit are isolated and sealed from each other so that any dust or moisture that may get up into the mechanical side of the unit will not migrate over into the electronics. We've designed a cable leveling supply pulley that eliminates any cable overlap or tangling, and so that when we let the line out and reel it back onto the supply pulley, it reels back on evenly every time. We've gone from a stainless steel cable with a tensile strength of 90 pounds to a stainless steel cable with a tensile strength of over 270 pounds. And it is the strongest cable of any unit in the industry. One of the inherent problems with some of the older bob systems was the cable slipping off the pulley wheels and then getting caught into the mechanics of the unit. So we've designed a captivated pulley system where every pulley wheel is captivated so that it is physically impossible for this line to slip off any of those pulleys. We've also fitted all pulleys with a sealed bearing to again assure trouble-free operation. Something else new on the SmartBob2 is a cleaning brush cavity that's easily accessible by simply taking the cover of the unit off. It has removable plates with brushes that can be easily replaced or cleaned, and the purpose of the cavity is to brush any foreign material off of that cable before it gets up into the mechanics of the unit. If there is some material that does make it up, we also have a pulley scraper which will scrape the channels of the pulley out so that material doesn't accumulate and pinch that cable. Air purge connections are standard and available on all units. And the last thing I want to talk about is an idler arm brake. The idler arm function is when it goes down and takes a measurement, when it touches the surface of the material, the idler arm comes back slightly to take up the slack in the unit, and then the motor pulls the weighted probe back to the neutral position at the top of the vessel. If we were measuring material with a real high angle of repose, or measuring during a fill cycle, or if this bob ever sunk in really light material, what would happen is enough weight would be taken off this bob that this idler arm would come all the way back and break the timing pulley, which stops the pulses, which reverses the motor and pulls the sensor probe back up to the neutral position at the top of the vessel. So it basically goes down, the idler arm comes all the way back, breaks the timing pulley, stops the pulses, and pulls the sensor probe back to the neutral position at the top of the vessel. And this is all done instantaneously. Electronic features. We operate on an RS-485 network, meaning that from our control source, we run a twisted pair shielded communication line in series to each remote. So one cable will go up to the first remote, back out, and daisy chain on. We can run up to 4,000 feet, and depending upon the communication source, we can operate up to 128 remotes on one network. The remotes operate on 110 VAC. Each are fitted with their own individual transformers. Wiring terminals are removable, making for an easier installation. We can cycle the unit with cycle buttons from the very top. So if we want to troubleshoot, we can actually cycle it while we're on top of the vessel. Our bin address settings. There are dip switch panels to set every remote with an individual address, so that when we go out to communicate, we know exactly which one we are communicating with. We have dual conduit entries, a water and dust tight sealed electronic cavity. We also have gone to a direct drive heavy duty reversible motor with electronic torque control to assure that we get full maximum power throughout the measurement cycle. And the way that we get a soft touch so that it doesn't come up and slam into this flange is we do that by controlling the torque at the top 12 inches of the retract cycle, so that we can protect the gears and we can also protect the components within the PC board. Because the SmartBob2 operates on an RS-485 network, it allows us many communication options. We can communicate directly with the PC using our IMS, our inventory management software, which gives us the ability to monitor up to 128 of our SmartBob2 remotes from a single software program. Some of the features of the IMS software include the ability to auto-scan, to send site status to a remote location, to network, to send output alarms to a fax, pager, or an email system. We also have the ability to remotely access the software from a remote location. So these are just a few of the features of this powerful software program. We also have what's called an SBC console, which is a SmartBob console. And the console allows us to communicate with up to 30 of the SmartBob2 remotes. And you simply go up, choose the silo that you would like to measure, hit the button that will take the measurement. The bob then drops, comes back up, and the information given on a LCD screen is the distance to the product, distance of the product, and the percent full of the vessel. The SBC can also work in conjunction with the PC. So if we have a loadout station, or we may have a truck driver that wants to take a manual measurement of a particular silo that he wants to unload into, he can operate the SBC from a remote location and still operate the system on the PC. We have an RSU, which is a remote start unit, which is the interface between a PLC or DCS and the SmartBob2 remote. And what this will do is you get a dry contact closure in from the PLC or DCS to initiate the measurement on the SmartBob2 remote. Digital information is sent back to the RSU, and an analog 4 to 20 milliamp signal is then sent back to the PLC. Each SmartBob2 remote will require a remote start unit. And last is the RDU, which is a remote display unit. This is a listening device that is addressed to the individual remote that it's going to listen to. So if we're controlling this, let's say with the PC, we initiate the measurement with the PC, and this will give us a remote display of distance of product, distance to product, and percent full of the vessel at the vessel. And also, if you want to share information with the PLC or DCS, it does have a 4 to 20 milliamp output also. SmartBob2 comes standard with a cast stainless steel spiked sensor probe. This is designed for powder and granulars with angle of repose. A hollowed 6-inch stainless steel inverted cone is designed for liquids. Teflon coated cone is available for sticky and corrosive materials. Hollow 4-inch spiked inverted cone is used for very light bulk solid and powders. Digestible bottle is filled with a substance compatible with the material stored in the vessel. It is called digestible bottle because it can pass through a rotary valve or screw conveyor. This probe is used to torpedo through a liquid to find and measure submerged solids in an interface application.
Here Todd demonstrates that even after the probe is stopped, it continues after a 1.5 second delay. The probe may be stopped if it swings into an internal support beam or falling material inadvertently hits the probe. The SmartBob2 has the motor strength on retract to lift a full bucket of water. It's strong enough to pull through the toughest applications. Even with a mixture of flour and silica sand thrown into the mechanics of the SmartBob2, the new robust design of the remote allows it to cycle through the buildup with no problem. SmartBob2 is built to cut through those demanding applications where competing systems and technologies fail.